What if I told you that you and your twin could live the exact same number of moments, make the exact same number of heartbeats, think the exact same number of thoughts, but when you meet again, one of you is 20 years older than the other? What if aging is not about how much time passes, but about how you move through space-time? And what if I could prove to you, using experiments we've actually done, that two people can age at completely different rates, that time itself passes differently for them, and that this has nothing to do with biology or genetics or health, but with physics? Stay with me, because I'm about to completely overturn everything you think you know about getting old. Aging is not a biological clock ticking at the same rate for everyone. It's a consequence of how you move through the four-dimensional fabric of space-time. And this means that some people are aging faster than others, right now. Your head is aging faster than your feet. Astronauts age slower than people on Earth. And if you could travel fast enough, you could age 1 year, while everyone else ages 50. This is not science fiction. This is verified reality. And it changes everything about what it means to grow old. My name is Albert Einstein, and I'm going to tell you the truth about aging, the truth that contradicts everything your biology teacher told you, everything your doctor assumes, everything you see in the mirror every morning. You think aging is caused by cells dividing, by DNA degrading, by metabolism and oxidative stress and all the biological processes that wear down your body over time. And yes, those processes are real, but they're not fundamental. They're not what aging actually is. Aging is the accumulation of proper time along your world line. It's the amount of time you personally experience as you move through space-time. And that amount is not the same for everyone. It's not universal. It's not determined by how many years pass on some cosmic calendar. It's determined by your path through space-time, by your velocity, by your position in gravitational fields. Two people can start at the same moment and arrive at the same moment, but one can age 10 years while the other ages 50. Not because of different biology, because of different paths through space-time. This is time dilation, this is relativity, and this is why aging is not what you think.
Let me start with the simplest case, the most direct example. Imagine two twins, identical, born at the same moment. One stays on Earth, lives a normal life. The other becomes an astronaut, travels to a distant star on a spaceship moving at 90% of the speed of light, then returns. When they reunite, the earthbound twin has aged 50 years, is now 70 years old, gray hair, wrinkles, weak bones, all the signs of aging. But the traveling twin, only aged 20 years, is now 40, still young, still healthy, still decades away from old age. This is not fiction. This is predicted by special relativity, proven by experiments. Time literally passes more slowly for the moving twin. His clock ticks slower. His cells divide more slowly. His thoughts occur more slowly. Everything about his experience of time is slowed down compared to his brother. But he doesn't feel it. From his perspective, time feels normal, 1 second per second. But when he returns and compares, he's aged less, experienced less time, is biologically younger than his identical twin brother. This is the twin paradox, and it's real. It happens. Time dilation causes differential aging, and this completely changes what aging means. Now you might be thinking, Einstein, this only works at extreme speeds, near light speed, which humans can't achieve, so this is theoretical, not relevant to real life. But that's wrong. Time dilation happens at all speeds. It's just more noticeable at high speeds. But even at normal speeds, even at walking speed, time dilation is real. It's tiny, imperceptible, but real and measurable. We've measured it. Put atomic clocks on airplanes, flown them around the world, compared them to clocks on the ground, and the flying clocks aged less, experienced less time, by nanoseconds, but measurably, verifiably. And those nanoseconds, their real aging difference, real time dilation, happening at airplane speeds, which means it's happening to you right now. If you move, you age differently than if you stay still. The difference is tiny, but it's there. Aging is not universal, not the same for everyone. It depends on motion, on velocity, on how you move through space-time.
And it's not just velocity. Gravity also affects aging. This is general relativity. Strong gravitational fields slow time. If you're deep in a gravitational well, close to a massive object, time passes more slowly for you. You age more slowly, compared to someone far away in weak gravity. This is gravitational time dilation, and it's happening right now, to you. Your feet are closer to Earth's center than your head. They're deeper in Earth's gravitational field. And because of this, time passes more slowly for your feet than for your head. Your feet are aging more slowly than your head, by nanoseconds per day, but measurably, verifiably. We've tested this. Put atomic clocks at different altitudes, one on the floor, one on the table, 1 meter difference, and the clock on the cable ticked faster, experienced more time, aged more, by tiny amounts, but real amounts. This is not theory, this is measured fact. Your head ages faster than your feet because gravity affects time, and time is what aging measures. Let me explain what this means, what aging actually is. Aging is not some biological process independent of physics. Aging is the accumulation of proper time. Proper time is the time you experience, the time your clock measures, the time that passes for you as you move along your world line through space-time. And proper time is not the same as coordinate time. Coordinate time is time measured by some external reference frame, some cosmic clock. But there is no cosmic clock, no universal time, only proper time. Time as experienced by individual objects moving through space-time. And proper time depends on the path, on the trajectory through space-time. Two objects can start at the same event and end at the same event, but if they take different paths through space-time, they accumulate different amounts of proper time. One ages more, the other ages less. This is the fundamental nature of aging. It's geometric. It's about paths through space-time, not about universal time passing, not about some absolute clock ticking the same for everyone, but about individual experiences of time, determined by individual trajectories.
Think of it like distance. If two people walk from New York to Boston, they both travel the same spatial distance if they take the same route. But if one takes a straight path and the other takes a winding path, the winding path is longer, more distance traveled. Same starting point, same ending point, different path lengths. Aging is like that, but in time. Two people can start at the same moment and end at the same moment, but if they take different paths through space-time, one with more motion or different gravitational exposure, they accumulate different amounts of proper time, different amounts of aging. One is older, the other is younger, not because of biology, because of geometry, because of the structure of space-time and how they moved through it. This is profound. This is what aging really is. And once you understand this, everything changes. Aging is not inevitable at a fixed rate. It's path-dependent, variable, controllable in principle.
If you change your path through space-time, you change how much you age. Now let me give you some practical examples, real-world situations where time dilation affects aging. GPS satellites. These orbit Earth at high altitude and high speed. Two effects are in play. They're moving fast, which slows their time due to velocity. They're high up, which speeds their time due to weak gravity. The gravitational effect dominates, so time passes faster for the satellites than for us on the ground. They age faster, about 38 microseconds per day faster. If we didn't correct for this, if we didn't adjust their clocks to account for the faster aging, GPS wouldn't work, would be off by kilometers. So every time you use GPS, you're relying on the fact that aging is relative, that time passes at different rates in different conditions. This is not abstract theory. This is technology you use daily, built on the reality of differential aging. Another example, astronauts on the International Space Station. They're moving fast, orbiting Earth at about 28,000 kilometers per hour. They're also higher up in weaker gravity. The velocity effect dominates, so time passes more slowly for them. They age more slowly than people on Earth, not by much. After a year in space, an astronaut has aged about 0.01 seconds less than people on the ground, 1/100th of a second, tiny but real, measurable. That astronaut is literally younger than they would have been if they'd stayed on Earth. Their cells divided fewer times, their DNA replicated fewer times, their heart beat fewer times. Not because of anything biological, but because they were moving fast, because time itself passed more slowly for them. This is differential aging. This is relativity. This is reality. And it means that aging is not uniform, not the same for everyone. It depends on how you move, where you are, how you interact with space-time.
Let me tell you about the most extreme case we know of. Black holes. Near a black hole, gravitational time dilation becomes extreme. Time slows down dramatically. If you could orbit close to a black hole's event horizon and then escape, you could experience a few hours while decades or centuries pass outside. You could age 5 years while the rest of the universe ages 1,000. This is not speculation. This is what the equations predict, what the structure of space-time requires. Near a black hole, time is so distorted that aging becomes radically different for observers at different distances. Someone hovering near the event horizon ages incredibly slowly compared to someone far away. And if they ever reunite, the one who was near the black hole is decades or centuries younger, has experienced far less time, has aged far less. This is the ultimate demonstration that aging is not absolute, not universal, but relative, path-dependent, determined by where you are in space-time and how you move through it. Now let me address what you're probably thinking. Einstein, this is interesting, but what does it mean for me? I'm not going to travel near light speed or orbit a black hole, so how is this relevant to my aging? And the answer is, it changes what aging fundamentally is. It reveals that aging is not a biological inevitability proceeding at a fixed rate. It's a physical process dependent on space-time. And this opens possibilities. If aging is time accumulation, and time accumulation is path-dependent, then in principle you could minimize aging by choosing certain paths through space-time. Stay in strong gravitational fields, you'll age slower. Move at high speeds, you'll age slower. These effects are tiny at human scales, but they're real, and they show that aging is not fate, it's geometry, and geometry can be manipulated.
Maybe someday, far in the future, humans will use this knowledge, will deliberately manipulate their paths through space-time to control aging, will choose to age slowly or quickly depending on their goals. This sounds like science fiction, but it's based on real physics, based on the fact that aging is relative, is path-dependent, is controllable in principle.
Let me ask you something now, because I want to know how you're thinking about this. Does knowing that aging is relative change how you feel about getting old? Does it make aging seem less inevitable, less frightening? Or does it make it stranger, more mysterious? Does it change your relationship to time, to your own mortality? Leave a comment below. Share your reaction, because this is profound. This challenges basic assumptions about what it means to age, what it means to experience time passing. And different people will respond differently. Some might find it liberating, the idea that aging is not absolute, that it's path-dependent, controllable in principle. Others might find it disturbing, the idea that time itself is not uniform, that different people age at different rates. So share your thoughts, let's explore this together, because even though the physics is clear, the implications are still being understood, and your perspective matters. Let me tell you about something else, the psychological impact of understanding relative aging. When you realize that aging is not uniform, that time passes differently for different people, it changes how you think about your own aging. You realize that the years counting up on the calendar are not the same as the time you've actually experienced, not the same as your proper time. Someone who's lived a high-speed, high-motion life might have aged less than someone who's been sedentary, not because of fitness, but because of time dilation. The person who moved more, who traveled more, who was in motion more, accumulated less proper time, aged less, by tiny amounts, but in principle real amounts. This is strange, counterintuitive, but true. And it suggests that maybe we should think about aging differently, not as years passed, but as proper time accumulated, as time actually experienced. And that's different for everyone, based on their path through space-time. And there's another implication. If aging is proper time accumulation, then your subjective experience of time matters. When time feels slow, when you're bored and moments drag, you might actually be aging more, accumulating more proper time. Now this is speculative. I'm not sure subjective time experience maps directly onto proper time, but it's interesting to consider because it suggests that how you experience time might actually affect how much you age, not biologically, but physically, in terms of actual time accumulation. This needs more investigation, more understanding of how consciousness relates to proper time. But it's a fascinating possibility that your subjective experience of time might actually correspond to physical time in ways we don't yet understand.
Let me tell you what I think is the deepest implication of all this. That aging reveals the structure of space-time. Every wrinkle on your face, every gray hair, every ache in your joints, it's not just biological deterioration. It's a record of your path through space-time, a map of the proper time you've accumulated. Your body is a clock, and it's measuring something real, something physical. The amount of time you've personally experienced as you've moved through the four-dimensional fabric of reality. And different bodies will show different amounts of aging because they've accumulated different amounts of proper time, because they've taken different paths. This is beautiful in a strange way. It means your body is not just a biological system, it's a physical instrument, a detector, measuring your trajectory through space-time, recording your proper time, showing the world how much time you've actually experienced. And that's what aging is, the visible manifestation of proper time accumulation, the physical record of your path through space-time. Now, let me tell you about the future, about what this understanding might enable. If we truly understand that aging is proper time accumulation, and if we can manipulate proper time through motion and gravity, then in principle we can control aging. Not biologically, not through medicine or genetics, but through physics, through choosing paths through space-time that accumulate proper time more slowly. This is not current technology, but it's not impossible. If humans ever develop the ability to travel at very high speeds, near light speed, we could use time dilation deliberately, could send people on journeys where they age much less than people left behind, could create scenarios where someone ages 10 years while centuries pass on Earth. This would allow for long-distance space travel, for reaching distant stars, for surviving the vast timescales of cosmic exploration, not by living longer, but by aging slower, by accumulating less proper time during the journey. This is how relativity makes interstellar travel possible, not faster than light travel, which is impossible, but slower than normal aging, which is real, which is physics, which is how we might someday explore the galaxy.
Let me tell you one final thing about what this means for how you should think about your own aging, your own mortality. If aging is proper time accumulation, if it's about the path you take through space-time, then every choice you make about how you move, where you go, what you do, it affects how much you age. In tiny ways, imperceptible ways at human scales, but in principle, real ways. You are not passively aging at a fixed rate. You are actively accumulating proper time based on your path through space-time. And that path is partly up to you. Where you live matters. High altitude means faster aging. Low altitude means slower aging. How much you move matters. More motion means slower aging. Less motion means faster aging. These effects are tiny, nanoseconds per day, but they're real, and they show that you have some agency, some control, some influence over how much you age, not through biology, but through physics, through the choices you make about your path through space-time. And more importantly, it changes what aging means. Aging is not failure, not deterioration, not something to fear or resist. Aging is time accumulation. It's the record of your journey through space-time. It's the proof that you've existed, that you've experienced time, that you've lived. And in the block universe, where all moments exist eternally, your aging body is beautiful because it's real, because it's the physical manifestation of proper time, because it shows that you were here, that you moved through space-time, that you accumulated moments, that you lived. And that's not something to mourn, that's something to celebrate. You are aging, which means you are experiencing time, which means you are alive. And in the grand structure of space-time, your world line from birth to death, with all its aging and change, exists eternally, is permanently part of reality, can never be erased. And that's meaningful, that's profound, that's what aging really is, not decline, but existence, not deterioration, but time accumulation, not something to fight, but something to embrace, because it means you're here, you're real, you're part of the eternal structure, and your aging body is the proof. Hit subscribe to keep exploring the deep truths of time and existence.